All right, let's talk about the range and the interquartile range. Let's look at a number line. Let's say that we have our number line stacked up here. We stack up our data on top of this number line, and we have a central point, but we have one outlier out here at the end. If we were to calculate the range of these data, that would go all the way from here to here. But we suspect, so that would be our range, right? That would be what is the minimum value up to the maximum value. But we have this guy over here in the end that is a little bit kind of an outlier. He's messing us up a little bit. We suspect that probably a more realistic range includes this value here, or ends at that value there. So we need to find some way of calculating the range that ignores tails. And so what we do is break our data down into 4 quartiles. That's where interquartile range comes from. So we have our mean is going to be somewhere right in here, or this is about the middle of our data. This means that 50% of our values are on this side of the line and 50% are on this side of the line, right? So that's not quarters, though. We need to break it down into quarters. So we'll split this in half and this in half. Now that's probably more like right there. Okay, and then we have, of course, our values here and here. And so what this means is that 25% of our numbers fall within that range, 25% fall within this range, 25 here, and 25 here. And so our interquartile range is just the 2 innermost quartiles. So the interquartile range goes from there to there. Okay, so the range goes all the way from here to here. This is the range. But from here to here is our interquartile range. And the advantage of the interquartile range is that it ignores, or it deals with, these extreme outlying values that were over here on the side. All right, so to calculate the range and interquartile range, let's start with this sample data set. X is equal to the sequence of numbers 2, 3, 3, 3, 4, 5, 6, 8, 8, 9, 10, and 10. So in this case, we have 12 variables, an n of 12, and they're already in least to greatest order, so it's our smallest to greatest, and so our range is simply our minimum value and our maximum value. And we would sometimes write this as the data range from 2 to 10. We also sometimes subtract them. 10 minus 2 equals 8. And so we would say that we have a range of 8. Okay, so that's the common range. The interquartile range is a little bit more difficult. We have to break our data down into 4 equally sized groups. And fortunately here, we picked this data set this way intentionally, but we have 12 numbers, so I'm going to move. There's our first group. Here's our second group. This 6 and the 2 8s are our third group. And the 9 and the 2 10s are our fourth group. Okay, so this is our first quartile. This is the second quartile. This is the third quartile, and this is the fourth quartile. Whoa, I didn't know I could change the color after the fact. Well, look at that. So here's the fourth quartile. Usually, though, when we refer to the second and the third quartile, we're talking about the boundary that separates the first and the second and the third and the fourth. And in this case, it's not too tough, right? This is obviously 3. This, we would say 8.5. But these numbers are actually based on the cumulative distribution function of the data, so it's going to be a little bit closer to the 8. So it'll be 8.25. It's not really important that we understand how that happens. But in this case, our interquartile range, we would say, goes from 3 to 8.25, or we could also do the math, 8.25 minus 3. And so we have an interquartile range of 5.25. Okay, and the value of the interquartile range is that if I had some large values, I mean, let's say that this wasn't 10, let's say that it was, 576, that still does not change the value of my range, or my interquartile range, but it would absolutely change the value of my range, right? My range would now be 576 minus 2, 574, but my interquartile range would still be 225. So the interquartile range deals with large outlying values like the 576 here, and in those scenarios is a much more accurate representation of. All right, let's calculate the range and the interquartile range in R. We'll zoom in here so that we can see what we're doing. The data set that we were using was the numbers 2, 3, 3, 3, 4, 5, 6, 8, 8, 9, and 2 tens. Okay, so there we have our data set. The range is very easy to calculate. You can either do the min of x, which would return the minimum, the max of x, which would return the maximum. Obviously, you could also do the max of x minus the min of x. You can also do range. Let's highlight all of those, and I will send those over on my Mac using the command return button. If you're using a Windows machine, you would do Control R. But let's take a look at what we got here. So our min is 2, obviously. Our max is 10. Obviously, when I subtract them, I get 10 minus 2 is 8. And when I use the range command, it reports 2 and 10. One thing that I could also do here, if I wanted, was dump the range into the diff command, which finds the difference. Right, so the diff command, obviously a difference, it subtracts the 2 from the 10, and it gives us 8. So multiple ways of calculating the range. The interquartile range, fortunately, rather than making us do all of the grouping and stuff by hand, there are 2 ways that we can do this. The summary command will report the values that separate the first quartile from the second, and the value that separates the third from the fourth quartiles. Or we can also do the interquartile range command, and that's all capitals. Send those over again, and let's take a look at what we've got. So the number that separates our first quartile from our second is 3. So here's our min. Here's the value that separates the first and the second quartiles. Here is our median, which is technically the number that separates our third from our second from our third. So that's right here, halfway between 5 and 3 is 5.5. The mean is 5.9, which in this case is not that helpful. And then the value that separates the 8 and the 9 is 8.25. When we were drawing it out, I said 8.5, but it's actually 8.25. This is based on well, this will make more sense after we talk about normal distributions, but it's based on the probability, the probability distribution function of the data. So it doesn't find the value that's actually right halfway in the middle, but it's 8.25, and then our max is 10. Okay, so the interquartile range simply just takes this 8.25 and subtracts the 3 from it and gives us that value. So if you want to say from 3 to 8.25, you can say that, or if you want to report the interquartile range as a single value, you would just say my interquartile range was 5.25. I think this is a little bit more common, but reporting both of these is, I think, more useful because your reader can do the simple subtraction and get to that value. So either way is acceptable.